In this video, I'm going to go through the answers to the extra practice problems that I put on Google Classroom for your Unit 4 mid-unit test. In this first problem here, we are told that the distance a person walks, d, in kilometers, is a function of time, t, in minutes, since the walk began. So right off the bat, I'm going to pick out a couple pieces of information that are super helpful here. If distance is a function of time, then that means distance is the output and time is the input. I think that'll help us figure some things out on these statements later. So for example, if we look at A, distance is the input. Well, that's just not true, it's the output. B, time of day is the input. Now, time is the input, but it's not time of day. It is time in minutes since the walk began. So this is also not true. On C, time since the person started walking is the input. That is true, right? That is exactly what they tell us. Time in minutes since the walk began. T represents the input. That is also true. D represents the input. Well, D is distance, which is the output, so that one's not true. The input is not measured in any particular unit. That is also not true. The input is measured in minutes. It's right there. The input is measured in hours. Also not true. And H, for each input, there are sometimes two outputs. Well, if this is a function, then we know for each input there is only ever one output. Plus, we can think about this logically and just kind of reason it out. If it has been 5 minutes, well, there's only one distance that I could have possibly walked. I can't have walked a mile and also half a mile. That doesn't make sense. So only C and D. Now, number 2. The height of water in a bathtub, W, is a function of time, T. Let P represent this function. Height is measured in inches and T is in minutes. So we're going to match some of these things up. Now, I'm going to start with the statements and match them to a function notation equation. So after 20 minutes, the bathtub is empty. So that means that the input is 20 minutes, and the output is that there's nothing left in the bathtub. Well, that is option D right there. P of 20, that's my input, equals 0. The bathtub starts out with no water. Well, again, that means the bathtub's empty, so my output is 0, and it starts out, that means the time, the input, is also 0. So that's option A right there. Okay, so we got those two done. After 10 minutes, the height of the water is 4 inches. So let's see, here my input is 10, right? Time is my input. So 10 minutes is the input to the function, the output is 4. That is option C here, right? Remember, input is always what's in the parentheses there. Now, B is the only one left, but let's just make sure that it actually matches. The height of the water is 10 inches after 4 minutes. Well, again, there's my input again. So input here, 4 minutes, and there's my 4 right there. So that does match up. That's option B. Number 3, function C gives the cost in dollars of buying N apples. So this is my input here. Number of apples that I bought. Cost is the output. So I want to describe what does each of these tell me. C of 5 equals 4.50. Well, this tells me here, remember, apples is the input, so 5 is my number of apples. This tells me that the cost of 5 apples is $4.50. And the second one is pretty similar, except there's no equals sign. This one, again, my input now is 2, which is 2 apples. So this tells me the cost of 2 apples. Now, I don't know what it actually is. I don't know the output, but I do know that this expression here means the cost of 2 apples. Number 4, function f gives the distance of a dog from a post. Hey, we saw this problem in class. In feet as a function of time, in seconds since its owner left. So again, distance is the output. Time is the input. So f of 20 means that time is 20. So I come over here, look at 20 is right there, and it looks like that is about 3 point, I'm going to call it 3.2 feet. So I'm going to say f of 20 equals 3.2. And then f of 140. So again, the input is 140. I come over here, and that looks like it's about 3.5. So f of 140 equals 3.5. Number 5, Tyler filled up his bathtub, took a bath, and then drained the tub. The function b gives the depth of the water in inches t minutes after he began to fill the tub. So similar problem we've seen to the one above. So again, input is time in this case. Right? Input is time. So that means all of these here are times. So explain what this means. After 0 minutes, or in other words, at the beginning, there is no water. I promise that's W in the tub. B of 1 is less than B of 7. So again, these are both times here, the 1 and the 7. But B of 1 means the amount or the depth of water at time 1 minute, or after 1 minute has passed. And B of 7 means the depth of the water after 7 minutes have passed. So the most the fastest way to interpret this is to say, this is telling me that there's more water in the tub at 7 minutes than at 1 minute. Or a little more specifically, the depth is more. There's more water in the tub after 7 minutes than after 1 minute. Okay, moving on to C. 9 again is my input. That is how many minutes have passed. So that means that this is saying after 9 minutes, the depth is, just want to make sure, water is measured in inches. The depth is 11 inches of water. Down here, these are both times, but remember, B of 10 means the depth of the water after 10 minutes. B of 22 means the depth of the water after 22 minutes. So we can say the depth of the water is, these are equal, so it's the same after 10 and 22 minutes. Down here, moving on to E, there's a long one. B of 20 is greater than B of 40. So here, this is telling us, again, both times, that the depth of water is greater after 20 minutes than after 40 minutes. Or in other words, there's more water in the tub at 20 minutes than at 40 minutes. Okay, done with that one. That was a lot of writing. I hope you can read my handwriting at all. Number 6, function f gives the temperature in degrees Celsius t hours after midnight. So again, f temperature, this is our output. And f is the name of the function. T is our input, so time is our input. And it's important to recognize that t is not going to look like, 3 p.m. or 6 a.m. It's going to just look like a number of hours after midnight. So the temperature at 12 p.m., this is noon. That means that this is f of, noon is 12 hours after midnight. So f of 12, and they don't tell us what it equals. So the temperature at noon is just f of 12. The temperature was the same at 9 a.m. and at 4 p.m. So here, all we have to say is the temperature at 9 a.m. was the same as the temperature at, now 4 p.m. is 16 hours after midnight. Let's make that equal sign a little clearer. It was warmer at 9 a.m. than at 6 a.m. Well, that means that my temperature after 9 hours have passed, if it's warmer, it's a bigger temperature, is greater than the temperature after 6 hours have passed. Sometime after midnight, the temperature was 24 degrees Celsius. So I don't know the time in this problem. I don't know how long it has been. So f of sometime t that I don't know is 24 degrees Celsius. Last problem. Function p represents the perimeter in inches of a square with side length x inches. Now perimeter, that's my output here. P is the name of the function. My input is the side length of the square. So let's first think about a square. Looks like this. If I want to find the perimeter, I have to add up all these side lengths. So if we look at like one example, if we look at 2, well, when I go to add these up, I have 4 2's. So the fastest way to find perimeter just seems to be to multiply by number by 4, actually. So if I have 4 zeros, I have the perimeter of 0. If I have 4 1's, I have perimeter of 4. 4 2's, perimeter of 8, and so on. So this will be 12 here, this will be 16 here, 20, and 24. So those are all my perimeters. And again, the math we were doing every single time is we were doing 4 times whatever the side length was. So if I want to write an equation now to represent that, that means that the perimeter for some side length x, right, the perimeter p of x equals 4 times whatever x is. So if x is 3, you do 4 times 3, you get 12. Now to sketch a graph of this, we can do this pretty quickly just by plotting all the points we found. So 0, 0, 1, that's not where 1 is. 1, 4, 4, 8, 3, 12, and so on. So I'm just plotting all the points we found. And it makes a nice straight line in this case. So we can connect the dots. We do connect the dots in this case because I can have decimal numbers and fractions, right? It's possible for a side length to be, 3.5, so I will connect the dots here. And that is actually our last problem here.